This product is legal in California for racing vehicles that shall never be operated upon a public highway. AEM holds no responsibility for any engine damage that results from the misuse of this product. Before we proceed, let's discuss why you'd want to use the FIC's O2 map to alter closed-loop air-fuel ratios. For many naturally aspirated vehicles, the factory ECU will try to maintain a fairly lean air-fuel ratio during closed-loop operation. On these same vehicles that have been converted to forced induction, it's possible to start making boost well before the ECU has gone into open loop. An air-fuel ratio like 15:1 is too lean for any appreciable amount of boost and can lead to poor performance and possible engine damage. Using the FIC's O2 map, we can make the ECU go rich where it originally wanted to be lean. The FIC does this by offsetting or reducing the O2 sensor's voltage output that the ECU receives. The FIC essentially makes the ECU think that it has gone lean, and to compensate, the ECU will now go rich. To begin, you need to know how much to offset or reduce the O2 sensor voltage output in order to make the ECU go rich. To do this, we conduct a simple test. The needed equipment for this test is, of course, the FIC, an external AEM F I C O gauge, and an OBD2 scan tool. Start by opening the Setup System menu. In the O2 section, set the load input to map, set the mode to offset, and input the bank high and low voltages. In this case, 1.1 volts for the high and 0 volts for the low. Now open the O2 map. All of the cell values should be 0. If they aren't, select all cells, right-click, select Set Value, and enter 0 and click OK. Now, with your vehicle parked, running, and fully warmed up, bring the engine up to 2000 RPM. Start inputting a small offset value into the entire O2 map. The narrowband output is reduced by the inputted cell value. For example, a cell value of -0.4 will reduce the output voltage of 1 volt to 0.6 volts. Start with -0.1 or -0.2 volts, and using your AEM F I C O gauge, read and record the new air-fuel ratio. At the same time, use your OBD2 scan tool and read and record the current short-term fuel trim. Continue to repeat this procedure and test for different voltages by decreasing the cell values with more negative numbers. Make your changes globally and use small incremental adjustments. Continue your testing and create a table listing the offsets and the corresponding air-fuel ratios and short-term fuel trims. In this graphic, you can see the list of voltages, air-fuel ratios, and short-term fuel trims we found through our testing. We started at -0.1 volts, but no change in the air-fuel ratio was seen until we inputted -0.35 volts. At -0.40 volts, the air-fuel ratio would drop down to 12.5 to 1. At -0.45 volts, we had an air-fuel ratio of 11.5 to 1, and at -0.50 volts, we had an air-fuel ratio of 10 to 1. Because of the limited operating range of a narrowband O2 sensor, you may find that small voltage adjustments make for fairly large changes in your air-fuel ratio. We now have more usable air-fuel ratios, and we also know the fuel trims needed to achieve them. The fuel trim information will be used later in this procedure. We can now go through the O2 map and designate specific air-fuel ratios based on load and RPM. In low load, we don't have a problem running the ECU's desired lean air-fuel ratios, so we can leave these cell values at 0 for no offset. In the part of the map where boost starts building while the ECU is still lean, we can offset or reduce the O2 voltage and make the ECU go rich. Here we'll go 13 to 1. In order to go 13 to 1, we'll input an offset of -0.35. And then here we'll go to an air-fuel ratio of 12.5 to 1, which requires an offset of -0.40. And then here we'll go with an air fuel ratio of 12.0 to 1, which requires an offset of negative 0.42. We can continue this upwards through the map for all load breakpoints. Now we need to compensate for these richer air fuel ratios by adjusting the fuel table. This step is extremely important and must not be overlooked. By making the ECU's target air-fuel ratio more rich, it will detect that the current condition is too lean, and fuel trims will increase to make the actual air-fuel ratio match the new desired target ratio. Over time, these short-term fuel trim changes will influence the long-term fuel trims, and the changes you make to the O2 map will eventually be trimmed out, and you'll be running lean again. To prevent this from happening, you must go into the FIC's fuel table and add in fuel to compensate for the richer target air fuel ratios. During your previous testing, you found the short-term fuel trims needed to satisfy the ECU's target air fuel ratio requirements. Use this trim information to adjust the fuel table where you've gone richer. For instance, on our table, for an air fuel ratio of 13 to 1, we had a fuel trim of 11. For an air fuel ratio of 12.5 to 1, we had a fuel trim of 20. For an air fuel ratio of 12.0 to 1, we had a fuel trim of about 26, and so on. Now you're going to essentially conduct a second test. The reason for testing your fuel map changes is that if you simply inputted the recorded short-term fuel trims into the fuel map, you'll most likely find that your air fuel ratios will go extremely rich. A more effective way to adjust your fuel map is to first input a smaller trim value and then slowly increase it until your air fuel ratios and fuel trims stabilize. An air fuel ratio of 13 to 1 had a fuel trim of 11. Like before, with the car parked, the engine running and fully warmed up, bring the revs up to about 2,000 RPM. Start out by inputting 4 or 5 into the fuel map and then use Control U for up and slowly increase the map value. If you go too far with your adjustment and start to go overly rich, use Control D for down and decrease the map value until your air fuel ratio and short-term fuel trim stabilize. Repeat this procedure for each different load level and air fuel ratio. Be sure to work slowly, making only small changes. Now that you've completed your O2 map, test your vehicle while monitoring your air-fuel ratios and check short-term fuel trims. Remember, the objective is to keep short-term fuel trims near zero. Adjust your fuel map accordingly to accomplish this. You may need to repeat the previous steps a few times until you've reached a point where your air-fuel ratios are easily controlled by the FIC's O2 and fuel map.